All right, so let's go back. This is part B. So here we have a system of equation where we can use substitution. Let's change the color. We've been using red all day. Let's do blue. There we go. Why not? So you can see right here that we can do substitution pretty easily because we know what x is. X is y minus 3. So we can take what x is and plug it into the second equation. Let's just look at the second equation first. So it's x over 2. And remember, x over 2 is also half x. Something to remember. Just like if I said x over 3 is 1/3 x. Right? And if I said, let's say, x over 10, well, x over 10 is 1/10 x, and so forth. So what we can do then is let's just make it half x. And you know what? Let's just do a different color again. Let's do green, a little lighter. So what if we did half x? There we go, like a neon. Neon green. Okay. Half x plus 2y equals 6. So we already know what x is. It's y minus 3. So we're going to substitute it in. We're going to take this and substitute it in. So we're going to have 1/2. Instead of saying x now, we're saying it's y minus 3 plus 2y equals 6. Okay, so I'll leave that up for 1 second if you want to copy it down before I erase it. Okay, so let's clear this out. So we know, give some room here, clear that out there. So we know we have half x, half y minus 3, because that's what x was, plus 2y equals 6. And then we can just distribute it in. So we're going to have 1/2 times y is half y, right? And then 1/2 times 3 is 3 over 2, plus 2y, because we're distributing here, equals 6. Now we got to combine like terms. So a half y plus 2y is 1.5 y, and 1.5 y is just 5 over 2y. And just get used to doing improper fractions. So it's 5 over 2y minus 3 over 2 equals 6. And then we're going to add 3 over 2 on both sides. We're adding 3 over 2. We get this complex fraction. And 6 plus 3 over 2 is 6 and 3 over 2. So let's just change the color again so we don't go back to red for a while. So now we have 5 over 2y. 5 over 2y is going to equal 6 and 3 over 2, which is 15 over 2, right? It's just 15 over 2. So we'll put 15 over 2 here. And 6 and see how we got that. Remember, 6 and 3 over 2. 2 times 6 is 12, and 12 plus 3 is 15. So now we got to divide out the 5 over 2. And whatever we do to one side, of course, we got to do to the other side. So here we have a complex fraction, 15 over 2 divided by 5 over 2. And that will give us 3, right? So y is 3. For all that, we got y is 3. But again, we need to know the solution, and we need to know what x is. So we have to find what x is. So now that we know the y is 3, close this out. We can look at any equation and put the marker back, right? And we'll change use like green again, why not? So we just, x equals y minus 3, and we said that y is 3, so x equals 0, right? Because 3 minus 3 is 0. So the solution set, remember y is 3, x is 0. The solution set will be 0, 3. Now be careful on if they give you the multiple choice question, they put 3, 0. Sometimes you rush and you put the 3, 0, but we're saying x is 0. And remember, x comes first. Okay. Let's get to inequalities here. System of inequalities, and If you know how to do the 0, 0 test, this gets pretty easy. So let's look at this. So here we have a system of equations, and here it is right here. So let's bring back our page marker, and we'll stick with neon green today, or winter green, whatever that is. So right here, we have y is less than or greater, less than or equal to. When you see a less than or equal to sign, it'll be a solid line. If it just said y is less than, then it would be a dotted line. That's something to remember, dotted line. But it is not a dotted line. It's a solid line. So we're saying y is less than or equal to 2x minus 3. So what we want to do with the 0, 0 test right here, 0, 0, is we want to know if we're shading in to the up on this line toward the origin or away from the origin. That's why we say 0, 0 test. So all we're doing is, instead of saying y, we're just saying 0. We're saying 0 is less than or equal to. And just plug in 0 for the x and y. So 0, and you got to get 0, because 2 times 0 is 0. So 0 is less than or equal to 0 minus 3. Is 0 less than or equal to negative 3? No, it's false. This is a false. If you get a false, very important, we'll put a star here. If you get a false, that means you cannot include the origin. So everything has to go away from the origin. That's why this is shaded. That's why that was shaded. If it was true, then you would go this way. But it's not true. It's false. So again, remember, it's false, shade away from the origin. And again, the origin is 0, 0. That's why we call it the 0, 0 test. Okay, so let's do another one. Get used to it. So let's look at this one now. This is a dotted line. See the dotted line? So we know that this would be, we'll bring back the neon green today, or winter green. So this would be a y is either greater, or it's going to be a y is less than, depending on if it passes the 0, 0 test. Well, let's find the equation first. Use an equal sign first and see if you can get an equation. So try that. Try to get the equation, pause the tape, and then we'll move it from there. All right. So if we just did put a domain and range box here, where we had x and y. So when x is 0, we can see when x is 0, y is 1 right away. And when x is 1, here's the 1, we can see y is 3. And we just need one more. When we see y is 2, we see x is 5. When x is 2, y is 5. So here we can see right away that it's going up by 2, that the slope is 2. It's going up from here. We can see it's going 1, 2, over 1, hits the line. 1, 2, over 1, it hits the line. So we know our equation, if we had an equal sign, would be y equals, the slope is 2, and it crosses at 1. Right here, it crosses at 1, so we have a plus 1. So we want to know now, is it y, and we have to use just less than or greater than. We can't use less than or greater. We can only use less than 2x plus 1. Or we can use y is greater than 2x plus 1. One of them work. And how do we find out? We just do the 0, 0 test. So if we make this 0, if we make y 0 and x 0, let's do it. If we make, for the first one, it would be 0 is less than 2 times 0 is 0. Yes, this works. This is true. So if we use this equation, that means we would have to go this way to include the origin. But we can't use that equation because they're showing that it's going this way. So that's why we're using this one. And let's check this one again. We're using a Halloweenish color there. Let's clear it out. Let's use another color, We'll just use green again. So if we did the bottom equation, if we said 0 is greater than 2 times 0, which is 0, that's a false. That's what we want. We want the false because it's showing it's false. It's showing it's going this way. It's going away from the origin. and we would fill that in right there. So just try to rewind the tape if you didn't get that one. Okay. All right, moving on. So here we see in action what's happening here. Now, let's look at this dotted line one. As you can see, it's saying y is greater than negative 3x plus 5. It's not saying greater or equal. It's just saying greater. That's why it's a dotted line. So we can put in, if we say 0 is greater, negative 3 times 0 is 0, and 0 plus 5 is 5. 0 is not greater than 5, and as you can see, it's going away. It's going away from the origin, that line, away from the origin. So we'll just shade that in so far like that, roughly. All right, and we'll change the color because it will get messy. This one, you can see it's a solid line, this one over here, because it's saying y is less than or equal, that's why it's a solid line. And then x minus 2. So again, we just plug in, we say 0 is less than or greater. 0 minus 2 is negative 2. So 0 is not less than negative 2. So what we would have to fill in away from the origin. We would have to fill in this way. And where they meet, where they both meet, is the solution. So then you would do another color here, right? So where they meet, we'll use blue. They're meeting right here. This is the solution where they're meeting. All this will be the solution where they're meeting. So all those within that shaded area are the solution set. That's how you do system of inequalities. Okay, so let's look at a linear equation word problem and see if we can create a linear equation. And we'll add in our marker. So it says the roller coaster was 15 feet above the ground. So we already have, so let's write it in general terms, y equals mx plus b. We're going to write it in slope-intercept form. And they'll ask you to write an equation in slope-intercept form. If they don't say slope-intercept form, that's what they mean. So we already have that it's 15 feet above the ground. It's its starting point. It's our initial starting point. So we have y equals mx plus 15. We have that already. Now we're just trying to find the slope. And it gives you the slope here. It says 9 feet per second. That's the rate of change. That is the slope. So we have our answer. Our answer then is y equals 9x. Let's just get that out of the way, Let's clear this and do it again. And we'll do a neon, why not? So we're saying y equals 9x plus 15. That is our equation based on that. All right. Here's another word problem. Let's try to do this. This one we have to be careful. You have to look at it carefully. So it says Fred charges $80. Fred Rogers. Who knows who Fred is, right? He charges $80 for the first, let's get the marker back up here. For the first 5 hours. Read this carefully, remember. First 5 hours. And then he's only charging $10 an hour after that. And we have to use C for cost and H for hours. So since the first 5 hours is just $80, we have to deduct those hours out. We can't just write it like this. We can't do this. We can't say the cost is going to equal 10 H. We can't do that. Plus 80, by the way. No, we can't do that because that doesn't include the fact that for the first 5 hours, it was just a set charge. So we have to get rid of those 5 hours. And to do that, we're going to say C, and then we're going to put it in parentheses here. We're going to put the 10, because he's getting $10 an hour. But, let's clear that out. Let's do this over. So we're saying C is going to equal 10, but minus the first 5 hours. Let's minus the first 5 hours out, and we'll get plus 80. And of course, we can't use X. We're supposed to use H. It says it right here. Use H for hours. So we'll fix that. And we'll use green. So if we do our distributive property, we're going to say C is going to equal 10H, because we're distributing. It's going to be 10H minus 50 plus 80. And you combine the like terms, and you can have C equals 10H plus 30. That's the equation for that. Again, the first 5 hours, it was only $80, so we can't put $10 in. That's why we're subtracting the 5 out. If you want to test this, well, for the first hour, it's going to be 10 times over here, right? 10 times 1 is 10. 10 plus 30 is 40, so he's getting 40 for the first hour. And for the 5 hours, it should be 80. So 10 times 5, 5 hours is 50, and 50 plus 30 is 80. So we know this works. And if we want to know what he would make in 6 hours, you just plug in 6 for H and stuff like that. Okay. Moving on. Now here we have a temperature. If we want to convert from Celsius to Fahrenheit, and most of the world uses Celsius. America and a few other countries are the only ones. So all we have to do, and even though this is a where you have to plug in, it's only 2 degrees, so you don't have to worry too much about having a calculator here. We should be able to do that. 1.8 times 2. You're just plugging it in. 1.8 C is 1.8 times 2 is just 3.6. So if we wanted to find the Fahrenheit, it's going to be just 3.6 plus 32. And make sure you line up the decimals correctly, right? It's 3. Oops. Erase that over here. It's 3.2. Don't do 3 like I was trying to do. It's 3.2, right? So it'll be 35.2 is the Fahrenheit. Still cold, right? Sometimes you're in another country and it's 2 degrees, and let's say you're in Italy. So it's 2 degrees Celsius. They might not say Celsius. They say 2 degrees. Well, it's 35.2 degrees. And if it was 40 degrees Celsius, we think that's cold, but that's actually pretty hot. So that is just a conversion, plugging in things. And again, be careful of lining up the decimals. Very easy, especially in the SAT when you're trying to rush or you're nervous and you don't line up the decimals. When you're adding subtraction, you have to do that. So here's a function of x, f of x. Just simply plugging in 0 for x here. And let's get our marker back. So, and change the color, why not? There we go. So we're just saying 8 times 0, which is 0 plus 2. So what is f of 0? F of 0 is 2. You'll get a few of those questions. Okay. Moving on. Let's look at this. This is a question we did previously. So we're trying to find, if it says if a is a constant, it's a number, and there is no value of x. In other words, that satisfies this equation. In other words, these will be parallel lines again. If there's no value, there's no solution. No solution, parallel lines, right? No solution. And if you remember, if they're parallel, they'll have what? Who remembers? They'll have the same slope. So we did a question like this before. See if you can work this out. Remember up here, pause the tape. You have to distribute. So do that, and then we'll work it out. Pause the tape. All right, so if you had a chance to pause the tape, let's get the marker back. Changed it. So let's distribute this first. So this would be 3x plus 15, and then it'll be 5x minus 5. That's just on one side of the equation. So if we combine like terms here, we should have 8x plus 10. 15 minus 5 is 10. So we know, if we look at the other equation, 2ax minus 15, we don't care about minus 15 and plus 10 anymore. All we're concerned is that they have the same slope. So what should a be? 2 times what gives us 8? Well, a should be 4. So when a is 4, 4 times 2 is 8. They have the same slope. And if they have the same slope, then there is no solution. There's no solution when they have the same slope. And they have the same slope when a is 4. So if you want to study that 1 second. Okay, close that out. Okay, and now we're up to quadratic equations. So let's make sure we know a few of these quadratics. And we'll have the first two we'll do is when a, so let's look at the terms. So when you have a quadratic, you have ax squared plus bx plus c. So we have the a term, the b term, and the c term. And we've done this before when we haven't done it before, but we're going to do it. And you have to be careful with the a and the b and the c terms. So in this first time, we're going to say with a is 1. When a is 1, there's a way of solving these. When a is not 1, it's a different way, and we'll do that in a minute. So let's get one here. Let's say we had x squared. It would help if we have a marker. Say we had x squared, and then we said minus 5x and minus 50. Why not? So what we want to do when you see this, and you can see that the a term, the a is here, there's a 1 here. There's a 1 here, so we know that a equals 1, and we can do this. We want to know what multiplies, what two numbers give us a product of the c term, negative 50. What two terms give us a negative 50, but at the same time give us a sum of negative 5? So negative 10 times 5 is negative 50. Let's change the color here. We know that negative 10 times 5 is negative 50, and negative 10 plus 5 is negative 5. So that works. So then we could just make our binomials. We're going to have x in it. We need two x's to give us the x squared. There's our binomials. And we're going to say x minus 10. And we'll say x plus 5. That's our two numbers. And we can check this with FOIL. You should be familiar with FOIL. First, outside, inside, last. We can just double check. X times x is x squared. X times 5 is 5x. Negative 10 times x is negative 10. And negative 10 times 5 is negative 50. If you're not familiar with FOIL, I'll do it very quickly just to make sure you understand. Let's do it down here. Let's just add another one. Back to red. Actually, let me clear out that. Erase this over. I'll do it slowly so you understand it. If you know FOIL, you can just fast forward the tape. Clean it out there. Okay, there's a smiley face. Creating a parabola. And you should know that quadratic equations will create parabolas. So we said that it was x minus 10, and then we said it was x plus 5. So first times first, the first term times the first term, x times x is x squared. And then we have the outside term, which is x times the outside term 5. That gives us 5x. And then the inside term for FOIL, negative 10 times x is negative 10x. And then negative 10 times 5 is negative 50. And then if you combine the like terms, you'll get this answer. Okay. Now remember, all quadratics are set to 0. So let's do another one. Let's say I had x squared. We'll do something easy here. X squared plus 7x. And let's say 10. So what do you think? What multiplies, what two numbers will give us a product of the c term, the last term, but add the b term, which is 7? Okay, so let's change that. Well, we know that 5 times 2 is 10, and 5 plus 2 is 7. So we'll have x plus 5 and x plus 2. There we go. Now what happens now? We have that where a is not 1, where a is greater than 1. Do something like that. When a is greater than 1. Okay. So erase this. Bring it back. When a is greater than 1, there's a different way of doing it. So let's just write an equation. Let's say we had 6x squared plus 11x plus 10. Let's do minus 10. It's easier, actually. Erase that out. Minus 10. Now, as you can see, the a term is greater than 1. So what we have to do, here's the rule of doing it. You're going to take the a term and the c term and multiply them together. You'll get negative 60. And then what you're going to do is take all the factors of negative 60. Now, don't worry about the signs right now. Just put all the factors, 1 and 60. And what you're trying to do is find these two numbers that will add to 11. So just keep going until you think you got 11. So 1 and 60, 2 and 30, and they should go down as the x goes up and the y should go down. I mean, as one side goes up, the other should go down. So you can do it this way, or whatever way you think is easy for you. Trying to get 60. Okay, and then we have 3 and 20, right? 3 and 20. Right, does that work? 3 and 20? No. And then we have 4 and 15. Okay, so 4 and 15 do work, but we have to know what sign. So negative 4 plus 15 is 11. So we're going to use this, 4 and 15. And it'll be negative 4 and positive 15. So let me erase that out. Just we're using 4 and 15. Remember, we multiply the a term and the c term. We got negative 60. So now I can erase this out here. As we hear some wind blowing. All right. And we'll use another color so we don't mess up. So we know now this is where you have to figure out the order. So we can say 6x squared. And then we need to know, are we going to put the 15 or are we going to put the 4 first? And I'll explain that in a minute, which one may work. So if I put the 4, let's just put the 4 first. And if it doesn't work, you just have to switch it around. And we'll say 15x minus 10. So now we should have 4 terms, which we have. And what you want to do is you want to cut them in half. So you're going to cut them in half. Just going to put a dotted line down there, right? Just make sure you know that that's a plus sign there. So we have 2 on one side, 2 on the other. So then we're going to factor them. So right here we can take out a 2 and we can take out an x. And then we make a parenthesis. And we want to bring it back. And we've distributed it back. How can we get 6x squared if we have a 2x? Well, we need a 3x, right? Because 3x times 2x is 6x squared. And to get a negative 4x, we need a negative what? Negative 2. So 2x times negative 2 is 4x. Now, on the other side, for this to work, and if it doesn't work, we have to change the negative 4 and the 15. We have to bring the plus 15 to the other side and negative 4 to the 10 side if it doesn't work. So over here, we can take out a 5, right? We can take out a 5. And to get 15x, I need 3x. So far, it's right because they both have 3x. And then we have a minus 2. So whatever in the parentheses has to be the same. It has to be the same. And it is. So we have our answer. So what we can then do on top, I'll just put it in red up here. The answer would be 2x. Take all the ones that are outside the parentheses, plus 5. And it's plus 5 because there's no negative there. That's one binomial. And the other binomial will be just 3x minus 2. And that's so we took our trinomial and we created our two binomials. clear that out. So in the next video, we're going to be talking about more, we'll talk about circles, and we'll do more stuff with the calculator also. All right, great job today.